Okay, yeah, so I have quite a lot of slides to rush through this morning. So if I go quite quickly, and I haven't completely lost my Scottish accent, if you miss anything, don't worry, all these slides are going to be available afterwards for you to check. And this is the kind of deck that probably benefits from being reread. You know, there's quite a lot of stuff in here about these APIs. A little bit about me before I move on. I actually moved to London to study music. After that, taught myself Python, so you're going to see Python referenced a little bit in here. And I came through to SEO after that. I went to work for Distilled, an agency many of you probably know, and now I'm at TensorFlow. On Python, it's fortunate that this morning you've already been introduced to other tools. You don't need to use Python. You could use something like 9. And fortunately as well, you've been taken through JSON formats and that sort of thing, which I'll refer to. So I'm going to talk a bit about NLP APIs and like how we started using them, or how I started using them in Distilled and then in TensorFlow as well. So it begins with, here we are. Back in Distilled, we had to pay attention to many different clients, keywords, rankings, and so on. Fortunately, humans are still essential. There's still a reason to employ me, but APIs aren't able to answer the question completely, and you'll hear me come back to this theme quite a bit. The point here isn't to automate or service out of existence, but we are dealing with large data sets, often in Distilled across many different clients, or with TensorFlow across many different countries and markets. And we knew that Google cared about things like topical relevance, and we still know that. But what does that actually mean that we should do? What should we do in practice? And around the same time, this was about 2 years ago, about a year and a half ago when I was at Distilled, we had lots of people started popping up saying things like this, using machine learning, we're doing something. And they're always kind of vague about how they apply it. Or there's this sort of fetishization of machine learning, really, or people just think it's a sort of magical cure-all for everything. And there is no denying the significance of it and the accessibility of it, which is great, because only a few years ago, you'd have had to have a PhD in this field. You'd have had to be a specialist. Suddenly, we have all this available, and you can. And I have been in a course at Google and read books and whatever. You can train your own machine learning models. It's cool that we can do this, but as with any new technology, and especially one that's quite difficult to explain, there's a lot of hype and noise around this. So you can use it, just not in the way where you're going to always sit and manually train your own models and do it in Python. The TensorFlow tutorials that you've seen are great and very interesting, but I've had very little application for them when it comes to actually doing any SEO. So this is a brief overview of what I talk about. I'm going to talk about how to build natural language processing services into your workflow without doing it all yourself. Algorithms, why that's probably the area that you shouldn't be looking at. It's the area that everyone talks about in TensorFlow tutorials and things like that. But you probably shouldn't do it. There are other things around there that you can add value. Along the way, I'll describe some examples of how I and colleagues at Distilled and TensorFlow have used this. So demystifying NLP, I'm not going to go all the way through a whole tutorial of tokenizers and parsers and all the stuff that the theory really that underpins NLP. Rather, I'm just going to reframe it. And yes, it's not about geekiness. I know, I just dislike this word. People always pop up and they talk about this sort of thing and say, it's all about understanding the different theory behind it and about being geeky and so on. It's really just a problem of scale. I just want to figure out how to analyze a large corpus of keywords or rankings in an efficient way and tap into somebody else's knowledge. In this case, people who are actually good at NLP, Google, IBM, Microsoft. And so, just to give you a bit of context, I have actually spent a lot of time playing around with machine learning, NLP, and this sort of thing. I do, if you want to check it out, actually, just as a hobby, not so much for your day job, check out this library here in Python. You can actually learn it from the ground up. That's not what this talk's going to be, though. But the thing is, I don't have, and like I said, it's a cool hobby, but I don't have time in my job. I don't have access to the same quantity of data that people who are actually good, companies who are very good at NLP have. That is Google, it's Microsoft, it's IBM, and companies like this, operating at huge scale. They have specialist hardware. You've probably seen Google has that TensorFlow chip that they've developed, deploying on Google Cloud. And also, I'm not dedicated enough to the task, to be perfectly honest. It's actually quite difficult to do NLP from scratch. You really do need to, if you're going to, you can begin and you can do the Hello World tutorials and TensorFlow and that sort of thing. But when it actually comes to putting something into production, that takes an awful lot of time and debugging. There are still some cases where you should do this kind of thing yourself, and I mean like totally in-house. Here are some examples where we do actually TransferWise. If there's very sensitive data, like we handle financial data, we're not going to put that up on the cloud. That's something that we can do in-house. We can build our own models and train them. If we have small data sets, this is another case where you don't necessarily need to tap into Google's power. Easily contained and domain-specific problems. Small data sets would be something like all properties in the UK. This is like a good practice machine learning thing. All properties in the UK or in California, and you look at square footage and number of bedrooms and things like that. See if they can predict price. This is quite a small problem. But when it comes to something like language, language is a huge problem, especially if you take it over multiple languages. There's very little point in relearning how to tag parts of speech. For example, like Google can figure out what the verb, where the verb is in the sentence, what the subject is. Trying to actually write rules, if you've ever tried it, in Python to do this kind of thing is a nightmare. It's also pointless because someone else has already solved this problem, or is solving it. You have things like punctuation, subtleties of language. If you're doing this on, say, social media comments, for example, you should tap into someone else who's actually solving this at scale. These are the people who are solving it at scale. So we have IBM, Google, Amazon, Microsoft, and others. All of them have APIs that we can use them. And we're going to look at one of them in some depth, because there is this happy middle ground where they take care of the stuff that's cool and the stuff that people like to talk up and develop something of a myth around in machine learning. Developing the algorithms, doing the research, the specialist hardware, investing in that sort of thing. But what we need to get better at is this. It's quite boring, actually, by comparison. It's sourcing the right data, preparing it, cleaning it, testing it, making sure you can use it with your APIs, and then just bringing those APIs into your everyday tasks, processes. So it's not really an intellectual challenge, it is just scale. You'll see how this works. TransferWise in a sec. So to give you an idea of why we're even investing effort in this, you go back to what gives TransferWise a competitive advantage. It's not any given keyword. It's actually not SEO directly. There are a few things, but one important element is cost, because we transfer money. If you haven't heard of us, the problem we were built to solve is transferring money from one currency to another, or across different borders. You go through your bank, this is usually exorbitantly expensive. Actually not because the banks are making a great deal of money at your expense, it's just that they're really inefficient. They don't really make any profit on it in many cases. And so we've been built from the beginning to solve this problem. And we're in competition with a lot of different people in what you might characterize as a race to the bottom kind of market, where whoever's cheapest in the long run is going to be the one who wins most of the business, especially as these different services become a little easier to use. Western Union has a website, it's not just in store anymore. Cost will matter. And that doesn't mean that we have no money to spend, but it means that we have to think about cost when we're developing strategies all over the business, and that includes SEO. It means that if we think to the future when eventually we'd like transfers to be free to the end user, or as close to it as we can, should we be investing in very expensive ways to scale out the keyword research and the publishing that we're doing? Or can we be more clever about this? Now, I mean, this second point here, reviewing every keyword manually, nobody wants to do this anyway. This keyword went up, this keyword went down. There are more scalable ways to work. And that's why we're thinking about this. So let's look at an example where we're going to analyze SERPs. So we're just going to look at the top 10, because that's typically all we're caring about, to topics, and trying to see how, if we're tracking, say, 1,000 different keywords, 10,000 different keywords, we have 10 to 100,000 different ranking URLs, and we want to see what kind of topics crop up, and that's where these APIs can help us. The toolbox that we use, and that we've used before at Distilled as well, IBM Watson. IBM Watson, if you're not familiar with it, is great. It has a really terrible user experience. They'll do everything possible to try and discourage you from using the website. I'm very reluctant even to link to it, because I know it'll be a 404 by the time I finish the talk. They move stuff about all the time. Microsoft Azure, which is actually, we all think of Google first when it comes to this sort of stuff, but actually Microsoft's APIs are a bit more generous than Google. They're a bit less cagey with these data. Google does have its own natural language API, which you can call, and I'll cover it briefly. And we need a good source for the data as well. Like I said, we need to get better at the stuff, not natural language processing itself, but all the stuff that surrounds it, which means we need good data. We need to have a solid rank tracker. We use Stat because the API is free, the pricing scales well, and the data are good. So this is IBM Watson. This page is probably not a 404 even at the time of writing. Head over here, you can sign up for their APIs. There's actually a fairly generous free allowance, which is more than enough to let you get started with this. And what IBM Watson is, it's been called various different things over the years. I think it started out as Watson Alchemy or whatever they've acquired it, and they'll have changed the name by the time I finish today. And what it is a whole different collection of APIs that IBM has been training for years on massive data sets that, practically you're not going to, you're not going to have access to that much data. You're not going to beat them, basically. It's hosted on IBM Bluemix, which is where you can run these services. So fully hosted, no provisioning of servers, any of that kind of thing. Yes, you'll be able to read this afterwards. It's not very easy to read. And I'll share the link as well. We have Microsoft Azure as well, which we use. This has a text analytics API. Mainly going to cover IBM today, but it's worth being aware of this one. These are a bit more generous than Google when it comes to extracting keywords in large numbers. So I'm just going to leave this in here. When you refer back to the deck, be sure to check out this API. Basically, if you feed in text, if you feed in an article to Microsoft, it's going to pull out keywords, basically like TF-IDF, but a bit more advanced. You'll have some garbage results in there and some good ones. This is the theme we'll come back to. This is Microsoft's documentation for that product. They're not much better than IBM. I'll see if I can find like a fresh link by the time I post these slides up. And Google Cloud, this is the other one. Google's natural language API is undoubtedly good, but they're just very reluctant, perhaps because they've too much experience dealing with SEOs, very reluctant to share any worthwhile and interesting data with it. So they let you plug into their sentiment API, which is supposed to judge if the sentiment in some passage of text is positive or negative. So you could use it, and we've tried using it on things like social media comments. We can see whether we're getting positive feedback. We can use it when people give us feedback and leave a net promoter score. Sometimes people leave us a score of 10 based on their experience and then say in the comment they were unhappy, or they say, great transfer, fantastic service, guys, and then leave us a 4. It's clearly a mistake. So we can use the Google's natural language API to calibrate that and figure out what the user actually meant, whether they like us or not. But we typically start with IBM, and that's what we're going to focus on. The reason we start with IBM is that, you remember our starting point is we have lots of different URLs that we want IBM to crawl and give us back the keywords and the categories and things that it finds. Microsoft and Google don't let you do it. You've got to provide the document to them. That means you've got to parse HTML, you've got to clean it, you've got to pass the text from the body into their API. IBM would do this scraping for you, which is nice. No more no more getting your IP blocked, that sort of thing. You can pass through URLs to IBM, it will crawl it. They're also really good. The other reason I recommend them is that they're really good at cleaning out they've gotten very smart at cleaning out all of the ads. So if you just, in a dumb way, scrape content off of pages that have lots of ads on them and pass them to the Google Cloud API or the Microsoft one, you'll get back an awful lot of keywords that are based on the ads and the kind of language that's in them. If you use IBM, it cleans all that stuff out. So it gives you back a neat version of the text. So I highly recommend it. So, brief introduction to IBM Watson. You can sign up. You get, I think, 5,000 free credits a month. It's plenty for you to get started. All you need is service credentials. Thankfully, you've been introduced to the JSON format already. It's very simple. It's just a username and a password. You're going to need to pass this along in the API. Highly recommend that you download PAW if you're on a Mac, and we're going to cover a cross-platform one in a second. What is PAW? It is it's a GUI interface so that you can learn and practice with APIs, and you can see the result that you get back. It's a lot more approachable than trying to throw yourself in the deep end with Python if you're not already doing that, or any other programming language. We have a cross-platform suggestion as well, which is Postman. Postman is free. PAW costs $50, I think. And then we can start to look at the kind of results we might get back from IBM. You're going to see some examples using PAW and Postman in just a sec. So, sorry, I skipped over that. Entities, these are one of the endpoints we can get out. So entities are, just like the knowledge graph. Basically, that's you going to IBM and saying we have this page or this collection of pages, this SERP with 10 URLs in it. What entities are being talked about on those pages? So for this keyword that we're interested in, what kind of people, places, this sort of thing are cropping up in your competitor's content and your own. These are great if you need to understand relationships in particular, because increasingly like IBM, Google, and the others are getting very good at mapping the relationships between the different entities that they find. And also, if you can put in some work, we're going to cover a more advanced way to use IBM in just a bit. Keywords. is another endpoint. It's another thing that you'll be able to pull out using IBM and the others. You know what keywords are. But they're very unstructured text, and you do get a lot of garbage results in there as well. So as I'm going to show you in a minute, you do need to be able to clean some of that stuff out. They are great, though, if you just need to rapidly expand a keyword set. So say you're tracking a keyword, you get your 10 URLs from the SERP, you put them through IBM, you'll get a whole bunch of keywords back. This is a really easy way to expand a keyword list and find things that have been talked about on this SERP that actually might be relevant elsewhere too. Categories, IBM renames everything all the time, like I said. Previously, these were taxonomies. They were taxonomies when I started writing this presentation. These are more structured and actually very useful, but less flexible. Categories is a more finite set. So IBM has decided in advance what the categories are. It adds new ones all the time. So it figures out, say, that TransferWise sits within a finance category, and within that, within a foreign exchange category, so on. It's actually quite a good way to, it's a little rigid. It's not going to fully explain how things rank. But it's a good way to conceive if you're looking at lots of different content spread across different keywords and you want to group them. Group, say, lots of different SERPs into different categories. These are very useful for that. Sentiment, like I mentioned, sentiment is a bit of a mixed bag. Like if you put in a neutral-sounding sentence, often it will misjudge that somewhat and think it's very positive or very negative. They're more interesting when combined with entities, which we're going to get to in a sec. Word of caution, with all of these APIs, the stuff that I said you need to get good at is putting good data in and also knowing what to do with it when you get it out. Like, it's not an excuse not to think. The APIs don't answer the question fully. They will not explain fully why something ranks. This isn't like reverse engineering the Google search engine. So we'll cover now how to make a request. These are good slides to refer back to if you try doing this at home. Read the docs. These are the docs from IBM. We can see the different endpoints we can pull out. You've already been introduced to POST and GET requests. I'd recommend that you use POST with IBM. It's just a bit more flexible and a bit easier to parse when you're going to see it in PAW in a sec. These are the different endpoints you can request. So you can pull out categories, concepts, emotion, entities, keywords, metadata, relations. These are all things that are constantly adding to this list. The most interesting ones for you are going to be concepts, which is definitely the best way to pick out themes. You can often pick out a theme that an article is about, even though the person who wrote that article hasn't mentioned the keyword, hasn't mentioned this concept in the article. That's very small. Never mind. All right, this is the API request and response in PAW. Don't worry, we're going to see close-ups of this stuff, but this is the PAW interface, and it's how you're going to learn. Up in the top left-hand corner here, we have this box. It's where you can create requests in this request pane. You've got this nice interface. You don't need to do any programming whatsoever. This is a lot nicer. This isn't working. Never mind. So what we have here is a post request, as you can see, and up at the top, where we're going to post to. This is this API endpoint. And where we can post in here is the JSON that says what features we want to extract. In this case, I'm going to extract keywords. I don't care about the emotion, don't care about the sentiment. I just want to extract 3 keywords from the page and return the analyzed text, which IBM is very gracious with. This is the raw request, which you can study in PAW, so you get to see everything as it's happening in real time and debug, understand what's going on. I'll just skip over it for now, though. And then what you get back is this response. You've already been introduced to JSON. The response comes back in JSON. It tells us here a little bit about how we've spent money with them or credits. And these are 3 keywords it's extracted. So in this case, this is the article I asked it to go and crawl. Now IBM has gone within this split second that I put this into PAW, gone and scraped this page, taken out any ads. We don't have any, but if there were any, that would take them out. Parse the text neatly, give us back 3 keywords, because that's all I asked for. Notice one of them is really pointless. So I've left this in purposefully for you to see that the data are not perfect when you use these. You have to apply some critical thinking to what you get back. But things like annual green card are more interesting. If we saw, for example, if we were looking at moving to the USA for expats keywords and the kind of articles that crop up there, people might talk about an annual green card, and that might not be something that we'd thought of in this case. Maybe we could start writing about it. We also get back the text. This is the cleaned, ad-free text IBM will return to you. So how might we actually use it at scale? We can categorize search results. That's our first way. So looking at a 10-link SERP, what entities are cropping up in that, get IBM to scrape all 10 pages and tell you what people are talking about, what's relevant. What categories and taxonomies can we find, and how consistent are these across all 10 pages. And it's actually pretty powerful because if you are tracking a large number of keywords, you can't do it all manually, you can't do it by hand. If you see, for example, for a given keyword, that there's a theme that keeps cropping up in the successful pieces, that's something that you may not have necessarily written about. That's something that can guide your content creation process. This is the sort of thing that we're looking for. How do we scale it? Well, across one SERP, we need response data from 10 pages together. This is less noisy than just looking at one. So in the one that I just showed you there, we had that sort of silly keyword that came back in the middle, straightforward process, which we're not going to write an article about. However, when you do this over all 10 pages, you won't see that keyword pop up in all 10. What you see instead is, annual green card might show up in 3 of them. We start to identify that's something that Google thinks is relevant to this other keyword, which was moving to the US guide for expats. So it gets less noisy as you scale it. Actually, it gets more useful. You can identify common themes run through all 10 pages. Then we do this across an entire set of keywords. Now you do need NIME, as you were introduced to earlier. You need something to automate, basically. I use Python, because that's where I kind of came from Python before SEO. So in the case of the script, which I'll share afterwards for anyone who likes coding, what we were doing is importing the top 10 rankings. That's coming from stat. Use a simple Python script to call IBM for each one of the URLs that were in each ranking, and then group the results you get back by entity, concept, to category. This will narrow down your search. So if we were looking at 1,000 different keywords, we'll have picked out 40 themes or something. It's a lot more manageable than trying to go through keyword by keyword, SERP by SERP. We instead just can identify the core concepts that we actually care about. How does this help? It doesn't mean that we don't put in the errors. It doesn't mean that we've automated ourselves out of a job. There's still plenty to do with that. You still have to plan how it's going to translate into an actual strategy to beat your competitors. But it does let us identify trends, spot topics. This is very inconsistent. It does let us identify trends, spot topics, and generate new ideas. And we can add one more dimension, which is time. This starts to become more powerful as you do it over time. So within TransferWise, one of the ways in which we're using it, we're seeing whether over time, based on some particular keyword, a set of keywords, are the topics that Google is deeming relevant, that Google is ranking, are they changing over time? Are our competitors starting to talk about some other related thing? Maybe annual green cards isn't the issue anymore. Maybe it's the laws that President Trump has introduced, or maybe it is something to do with HB2 visas. Maybe they become more relevant. We can start to identify where they're bubbling up, those concepts and those entities in different SERPs. Categories for IA. This is another one. This is less ambitious, a lot easier for you to do, but it's another way in which you can use the response you get back from the API for information architecture. Case here would be, you can do it for client side. Again, it's not about giving you an answer out of the box, but just narrowing down your search. If you're looking at, you have a lot of different content spread over a blog, say, you have dozens of different categories, thousands of different pages. Use your crawler of choice to fetch all pages, send those URLs to IBM. You will get back taxonomies. IBM will categorize all those pages together in a way that it thinks makes sense. This is not necessarily the final answer, like I said, but it's like a second opinion. So it's like IBM very quickly going through your entire site and saying, here's how we think this content makes sense, should be organized based on the actual content, not based on the navigation, not based on the title tags or any of that stuff. So it's quite a good alternative view. You could have misaligned categories on your website, and IBM can help you correct it. We still haven't covered the best feature, but this one does require you to put in a bit more work. And that is you can use IBM and a feature they have called Knowledge Studio to build your own knowledge graph. So you're not only relying on Google's, you can actually make a more more domain-specific one. So what is this? It's a graphical user interface for annotating text. This actually helps us to train IBM. So you are doing machine learning, but you don't have to do any programming, or worry really about how it works under the hood. And it will allow you to get richer data from the SERP. Knowledge Studio looks like this. You can see some examples of, we'll see a more close-up in a second, of how it actually works. It helps you annotate text. And what we do is, say we're looking at a bunch of different keywords that have to do with currency conversion. There are certain entities that Google may not be aware of that don't show up in the knowledge graph, but which do matter to us. So in this made-up example, I've said, I want to identify currency pairs in search engine rankings. I want to identify comparison sites, because you have a few of them that compare the cost of transfer across different providers, TransferWise and its competitors. And let's also say that I care about foreign exchange brokers as an entity. Like Google is unlikely to, by itself, recognize that a company is a foreign exchange broker and then feed that information back to me, but I can do it here. So define the entities that you care about. You can place a document in the queue. We'll cover what the queue is in a sec. place a document in there and then highlight the entities that you actually care about. In this case, I'm teaching IBM just by clicking. I haven't got a GIF, but by clicking on this and then clicking on this, it's literally that easy. I'm teaching IBM that this is a currency pair. I'm teaching IBM that this made-up brokerage is a foreign exchange broker. And then I can highlight the relationship between them. I can click on the foreign exchange broker and then the currency pair and say, this is a product offering. Foreign exchange broker offers currency pair. In this way, I'm developing a much richer knowledge graph. I don't need to just rely on the entities that IBM gives me back. It means that when I parse all those same SERPs I told you about earlier, pass them into IBM, it can make sense of the relationships and understand much more. Are foreign exchange brokers popping up a lot, mentions to them in particular search engine rankings? Are people talking about some currency pairs more than others? And so on. So simple is GUI-based machine learning training, no programming involved. The only somewhat technical step is you sitting down and thinking about what entities you care about. If you could design a knowledge graph from scratch, what would it have in it? But beyond that, it's as easy as highlighting words. And it's pretty easy if you have people who do proofreading for you, if they're writing articles, to build this into your process so that they then do the clicking and the annotating afterwards. It doesn't require any technical skill. Do you publish content? You can do this. You can fit this in. Define the entities you care about in advance. You sit down and do that. And then people will plan the stuff you're going to publish in your blog, you write it, you proofread it, and then as a natural step at the end, just put the text from your blog post into IBM Knowledge Studio, click on the different words, teach IBM what those things are. It takes 2-3 minutes per piece. You can also go and take text from your competitor sites, drop it in there, and annotate it.
There are catering outlets on every floor. There are catering outlets available on every floor of the Brighton Centre. Thank you.
Yeah, there are catering outlets on every floor. I can confirm. So yes, and less excitingly, you have a scalable system with NLP if you do this. To give you an idea of why that's even promising, there is, somebody else thinks it is as well. You notice if you go and check out the docs for Google's Natural Language API that they care about this too. They're actually starting to build out a new endpoint, so they give you entities, which is just the knowledge graph. They give you sentiment. They're starting to build out entity sentiment, which they charge more for, which is where you ask them, you put in some piece, and they'll try and determine how people feel about the different entities. So it recognizes, say, President Barack Obama, we all know that example, but it can also recognize whether this article is complimentary about him or negative or whatever. And in a similar way with IBM, we're doing this ourselves. We're teaching IBM our own custom domain-specific knowledge graph, specific to your industry, be it the travel industry, foreign exchange, whatever. You can start to teach it who your competitors are. You can start to identify if people are saying positive or negative things about your competitors, about you. More or less, we're building this, but with IBM's help. How do you get good at it? Lay the proper groundwork, yeah. So this is what I was saying at the beginning. Don't get carried away by the hype. Don't try and build your own natural language processing framework and worry about algorithms and so on. Don't do that kind of thing. Remember that this is a made-up statistic. 94% of all statistics are made up. But almost all the work in machine learning is boring. Try that having done it. Almost all the time you actually spend is spent cleaning and processing data and making it ready for the algorithm to learn from. Making sure that things are regular, cleaning out punctuation, all that kind of stuff. Do be responsible for things like this. Scrutinize your sources. Make sure you work with a high-quality rank tracker if you're going to study ranks. Garbage in, garbage out. Smartest algorithm in the world won't do anything useful for you if you're feeding in ranks that you've scraped from an IP address in Romania where you're trying to emulate a US visitor. Spend a bit of money on the rank tracking. Like I said, stat is my recommendation. Preparing, cleaning the data, and then combining them and spotting ways to integrate these services. By that, I mean we're looking at our publishing process and seeing how could we get people who are writing stuff for us anyway to annotate the text that they're putting in and teach IBM what any of it actually means. So here's one way to do it. You don't need to do it this way. You can use KNIME instead. Sign up for a few of these services. This costs you nothing. They all have a pretty generous free allowance, more than enough to test, 5,000 free credits in a typical case. Use Postman or PAW. Don't challenge yourself to do programming immediately unless you already know it. Just download one of these apps. They're really nice to use. Explore. Just look at the output, the JSON that you get back. Just think about how you can use it. Don't rely on me to tell you exactly how to use it. Then if you want to go on, you want to scale this up, alternatively, you could use KNIME because that's been mentioned. But if you want to do it this way, my way, learn Python, start small, just focus on something simple like loops. All we're doing is sending a request to IBM. You figure out two things: how to make a request to IBM with Python, how to perform a simple loop so you can loop through the 10 URLs that you have and send each of them off to IBM. This is quite simple code if you want to learn it. Just start small. If you want to really take this further in the way that we have, you've got to do something with the output that you get back from IBM. All that JSON has to go somewhere. You have to group it logically. You can learn about pandas if you really want to get into the data analysis side. Pandas with an S, not Google Panda, not Panda algorithm. This book is great if you want to get into that stuff. Python for data analysis. This is actually written by the guy who wrote the pandas library as well, so he really knows his stuff. Find or create useful data sources. This is your annotation. This is your rank tracking. Get good at collecting that and processing it automatically. That's the sort of simple, boring stuff that you can automate with a bit of Python or using 9 to chain together a custom workflow. Step 3 is a bit everyone talks about in these talks, but it's just some fancy NLP stuff that you don't really need to know exactly how it works. It goes off to IBM, you get the answer back. Get good at collecting and organizing the output. That's the panda stuff that I referenced. And analyze and draw conclusions. You see, the truth is, like almost everybody who is talking about NLP and machine learning and ambitiously sort of dreaming up ways in which they might use it, usually haven't done these other steps first. They usually haven't prepared to the point where they have a data processing pipeline into which machine learning can fit. It's only after you solve steps 1, 2, 4, and 5 that you can start to go training your own custom models and doing things that are more ambitious. Before that, you should just rely on IBM, Google to do the heavy lifting for you. Basically, do these things. Your organization is well placed to make use of natural language processing. Maybe, as a last step after all that, you might invest in your own. Thank you. Nice to have you.